Hey guys, we took a quiz and then we did this activity, how many pairs of shoes do you own? So depending on the class, the data was different, but you should have a dot plot, a stem plot, and a histogram. And if you were absent from class, you can create this data. You can kind of guess what people would say. So I'm just gonna, I think we had quite a few people that said 5, maybe a couple people who had 6, maybe some people who said 10, 11, 12, 13. Again, I'm just kind of making up data that might make sense. Okay. So here's some example data I just kind of made up in my head. And my key looks like this. If it says 0/5, that means 5 pairs of shoes. So that's the other thing is if we took a test on this, you need to make sure that you have a key that explains what this stem plot is. Now our dot plot would also look something similar to this, right? It looks like I have 3 dots at 5. 5, 10, 15, 20, 25, 30, 35, 40. Again, I made up some numbers and I'm doing this quickly. You likely have data from class unless you were absent. So I had 3 5s, 1 6, 3 10s, an 11, a 12, a 13, a 23, a 24, a 35, and a 42. Okay. That's my dot plot. This is definitely quantitative because I'm not asking yes or no. And you know what? I don't know. I would probably say about somewhere between 15 and 20. I'm not sure I could answer that question. Take me some time to think about it. Now my histogram, I want to show you something really interesting. My histogram would look like this. Do you notice how my stem plot actually lumps it in tens? So you may have had a histogram like this, or it may have different widths. That's totally okay if you didn't have a width of 10. Again, I'm just giving you some examples. Here I have 4 that are less than 10. So 4 are less than 10. 1, 2, 3, 4. And then it looks like I have 6 from in the 10. So 1, 2, 3, 4, 5, 6. So 4, 5, 6. And then I have 2 between 20 and 30. And I only have 1 35 and 1 between 40 and 50. Okay, so here's my histogram. List the mean and the median. So again, that would be based on the amounts that you calculated. So that is, you add up all the dots and divide by the number of dots. And that's how you're going to get your mean. And your median is your middle. So you got to find your middle. So I'm going to do that now. It looks like I have 3 5s, and I'll cross out 3 high dots. I got a dot here and a dot there. Right, so those are all crossed out. Then I have this dot and this dot, this dot and this dot, this dot and this dot. Okay, so the middle is between 10 and 11. So my median would have to be the average, or 10.5, okay? And that's just me, right? I'm not going to go ahead and calculate the mean, but I did calculate the median, okay? Now, to describe the shape, outliers, and center, if I look at my data, this data looks like maybe 35 and 40 are outliers. My center is my median and my mean. my spread outedness. So it looks like the highest was 42 and the lowest was 5. So one measure of spread would be what's called my range. So for now, that'd be one way to think of it, right? So my students ranged from 37 pairs of shoes. And then with my shape, I want to talk about this. This actually does a pretty good job of showing me shape, a histogram. This is harder to see shape because it's kind of all spread out. It's not clumped up enough to see shape. So a shape, my choices for shape would be that would be a shape that's symmetrical, and that doesn't look like what we've got there. This would be a shape skewed right. And this would be a shape that's called skewed left. So it looks like my data, and again, depending on the class, you may have had skewed right, probably skewed right. And for now, let's just think about those shapes, symmetrical, skewed right, or skewed left. And then you have to make a call. Which of the three displays did you like? And there's a lot of reasons why. So I'm just going to pick the histogram because I could see shape easiest. And it really could be any answer. I actually saw preferences for, I think all three. The stem plot shows shape. You just kind of have to turn your head to the right, and you still get to see individual numbers. Here you can't see individual numbers. So they have pluses and minuses. Okay, so now with kind of summarizing what we've done here, let's check our understanding, right? So it says, Mr. Wilcox is a huge fan of the University of Michigan football. His favorite season was 1997, a perfect season, meaning they didn't lose any games. The dot plot shows the number of points scored in the 12 games. So that tells me there are 12 dots. And this is a dot plot, right? Now it says use the dot plot to create a stem plot. Now you can put these numbers in Statlet, or you can watch the video, right? Which is what you're doing now. And Statlet may or may not use the same. I'm gonna write, so my lowest number is 14. So I think I wanna use that stem, right? That would be 14. And I'm just kind of thinking what I'm doing here. I'm not doing it yet. My largest one would be this. And that would be 38 points, right? So I need to make at least a stem plot with 1, 2, and 3. In fact, although if we did one like the one a minute ago, we had at least 4 stems. So I'm actually going to make one with more stems. So if I had the lower part, so that'd be 10, 11, 12, 13, 14. 10, 11, 12, 13, 14. I have a 14. Then 15, 16, 17, 18, 19, 20, I don't have. Then the second one, I've got 20, 21, no 22s, 2 23s, a 24, right? And then this would be where I'd start 25, 26, all right, 27, 28. And it jumps 30 up to 30. I could have 34. And then the upper part of the 30 range, it looks like I have 37 and 38. Excuse me, 7 and 38. So my key is that 3/7 is 37 points scored in the game. Now, describe the shape of the distribution. What I'd like you to do is think about what this looks like, and you turn your head to the right and see, right? Again, it's totally okay if you made it just with 2. I'll make it a little easier. Probably more of you made it this way. We had 14, 20, 21, 23, 23, and 24, 26, 27, 28, and then 34, 37, 38. Notice what I've done here is just varied the width of the bar. Here, the width was 5, and here the width is 10. Now, this actually makes it a little easier for me to see the width. It looks like it's pretty much even on both sides. A few more numbers here, but it's pretty much all peaked in the middle, right? So I'm going to call this symmetrical, but it's not perfectly symmetrical. It looks like pretty much humped in the middle, a little bit more on the left than the right. So we use this word roughly to mean not exactly symmetrical, all right? Now it asks, are there any potential outliers? Well, if we look up here, it's possible that these numbers are really far from our center. If our typical number is somewhere here, I would say maybe, we're not sure, but maybe 37 and 38. And it says why? So because they're far from the center. Okay, so what measure of center is most appropriate? I'm not sure. I think in one class we talked about this, another one we didn't. The mean is best when it's symmetrical. The median is best when it's not symmetrical. So in this instance, since it is roughly symmetrical, I'm going to say mean is best, right? And so it says you have to explain. I picked one, and so I have to explain. What is the best measure of center? Mean, and we always repeat the question as well. So what does the question say? What is the measure is most appropriate? Mean is most appropriate to describe, I'm just repeating the question, the distribution because the data is symmetrical, is roughly symmetrical. Okay, so almost done with kind of summarizing our lesson here. I just want to go to notes. And again, this is probably not for everybody, but definitely for a couple kids that were absent. Okay, so scanning up to the top here, what were some important ideas? Notice our first learning target we talked about on the other page was the shape, right? We can talk about the shape when we're talking about quantitative data. And we got to see a few examples of that. Our data was skewed right. Normally, lots of people had a small amount of shoes and a few had a lot. Other times data is skewed left. That's when not a lot have small numbers and a whole bunch of people have a lot higher numbers. We talked about symmetrical data. That's when most of the people are in the middle and a few are low and a few are high. And last but not least, I didn't mention it before, but this does come up every now and then, bimodal. So this would be like girls' height and boys' height. So if I took the heights of the ladies and then maybe the ladies' basketball team and then the average height of the boys' basketball team, you might see two humps. One hump is the boys, quite a bit taller, and another hump is the girls, quite a bit lower. Bimodal. Now, the other learning target this lesson touches on is we did for the first time, and we're going to do this many, many times in the future, we learned about describing distribution. So notice we spelled out this term. I don't know if you noticed it or not, but on the last page, it's spelled out right here. We want to talk about the shape, any outliers, the center, and the variability. So we are usually asked and must provide the shape of the data, any outliers if we see it, the center of the data, and of course you want the best measure of center based on the shape, and the variability. Okay, so how do we go about doing that? We want to, in general, use LY words, okay? And because we're describing, right? Use descriptive words, adverbs, right? Adjectives. And remember, if it's symmetrical data, we're going to pick the mean because that's the best measure of center. And if it's skewed, or let's say it has a lot of outliers, which is why it's skewed, then you're going to pick the median because it's a better measure of center. The variability is how spread out the data is. There's multiple measures of center, but we talked about the range. So notice these points, that's a pretty big point spread. Their highest scoring game was 38 and their lowest scoring game was 14. Okay. Now, last but not least, probably the most important thing is to also include context. This is what so many students leave out. So that means if you're looking at data that's about a football game and the score of a football game, then when you're describing the distribution, you want to use the scores of football games. Use the words that the problem talks about. Okay, that's all I have today for you guys. See you next time.